Good morning. My name is Andrew McGee, and I was scheduled to give the last talk of this morning's Mettler session. Unfortunately, I developed COVID a few weeks ago, and it was quite severe, and I required Paxlovid. As a result, I still test positive when preparing this talk, so I decided not to attend the 50th NATAS, both for your health and mine. Instead, I prepared this video of my talk, which is a summary of the 60 years I've spent doing thermal analysis. Most of that time, 54 years, has been spent at the Laboratory for Research on the Structure of Matter at the University of Pennsylvania. I was fortunate to receive the Mettler Award in 2011, and I am proud to join the other distinguished recipients. I would like to dedicate this talk to my friend, neighbor, and colleague, and co-author, whom I first met almost 60 years ago, Gilbert Sloan. Unfortunately, Gilbert died last year at 94 and was still volunteering in my lab a few months before he died. I thought I would start my story in 1941. This is the cover of a book about the Clydebank Blitz in Scotland during the Second World War. It was written by my high school history teacher, Dr. MacPhail. The cover photo is the street that I lived in until I was 18 years old. Here is a better photograph of the street. 2 nights of saturation bombing by 240 planes devastated the town of 12,000 homes, with only 12 left unaffected by the bombing. I lived in the tenement on the right. Incidentally, Anne, my wife of 60 years this year, who many of you know, lived as a baby in the destroyed building on the left until the second day of the bombing, when her house was destroyed. Fortunately, she survived. Here is an aerial view of this area. A large cleared area in the center was full of tenement buildings. My street is the one still standing at the top center of this photograph. This area was not rebuilt until the late 1950s. After graduating from Clydebank High School in 1958, I attended Glasgow University for a BSc degree in Applied Chemistry from 1958 to 62. This course was part pure chemistry and part chemical engineering. Because Glasgow did not have a chemical engineering department, these courses were given at the Royal College of Science and Technology in Glasgow, which was founded in 1792 and which later became the University of Strathclyde. I subsequently obtained a PhD at Glasgow University, though the work was done under Professor John Sherwood at the Royal College of Science and Technology. My thesis title was Tracer Studies of Diffusion in Hydrogen Bonded Solids using tritium and carbon-14. During 1962 to 63, I did my first thermal analysis experiment, measuring the freezing point of pure benzoic acid, and built the following apparatus based on the classic work of Schwab and Vickers on benzoic acid at the National Bureau of Standards in 1940. This freezing point apparatus was used to measure benzoic acid and agreed with the results of Schwab and Vickers to within 0.05 of a degree. Repeated measurements, however, showed a slight lowering of the melting point by 1/10 of a degree due to absorption of water. This effect was also observed by Schwab and Vickers. Note that in 1963, that was also the time when Mettler introduced their first DSC. Following my PhD, it was standard practice in Scotland to get a BTA degree, i.e. been to America. So I spent 2.5 years working at the Franklin Institute Research Laboratory and the Chemistry Department at Drexel University from 1966 to 68 with Professor Mortimer Labus as a postdoc, who at that time founded the Journal of Molecular Crystals and later Molecular Crystals and Liquid Crystals. I returned to Scotland and spent a year at the Arthur D. Little Research Institute from 1968 to 69 as a research scientist with Dr. Alan Sharples, mainly doing thermally stimulated conductivity studies of polymers, especially polyvinyl fluoride. I was unhappy in this position and I returned to the United States and took an industrial postdoc at DuPont Central Research Department, 1969 to 70 with Gilbert Sloan, and the rest is history. I joined the LRSM at the University of Pennsylvania in 1970, and I am still there. This is the LRSM lab, which was built in 1962. The LRSM was established as one of 3 Department of Defense Materials Research Laboratories in 1960, following the Russians' deployment of Sputnik in 1957, when we were lagging in the space race. The others were Cornell and Northwestern. It became an NSF MRL in 1973 and a MRSEC Materials Research Science and Engineering Center in 1995. So it has had continuous funding from 1960. I joined the LRSM in 1970 to set up a central facility for purification and growth of organic materials. In 1990, I was appointed Associate Director of the lab with additional responsibility for educational outreach programming. In 1997, I was elected an honorary faculty member of the Materials Science and Engineering Department. Now, in addition to purification and crystal growth, thermal analysis gradually became much more useful in my lab. And here is some of the equipment that I've used over the years and obtained for the lab: DSE, DTA, TGA, SDT, DMA, TMA, TG mass spec, and hot stage microscopy. In addition, I have put together combinations of these techniques, such as DSE with dielectric thermal analysis, DSE with thermogravimetric analysis and X-ray analysis, and thermogravimetric analysis with pH determination of evolved gases. Here is a summary of my publications. On the Web of Science, I had 92 publications, and published conference papers not included in the Web of Science, over 35. Published 1 science book, Techniques of Melt Crystallization with Gil Sloan, in Techniques of Chemistry, a Wiley Interscience publication. 1 patent, an apparatus for fractional sublimation, and citations 6,512 at last count a week or 2 ago. 1 paper on C60 Buckminster fullerene has had 1,783 citations. Co-authors, I have more than 160, and my H index is 30. Here is the cover of our book on Techniques of Melt Crystallization, which includes some information on thermal analysis, which was published in 1988 by, as I said before, Wiley Interscience. I must say that I have enjoyed working at the LRSM for the last 54 years. If I hadn't, I would not still be there. It's also been an opportunity to collaborate with many distinguished scientists on very interesting problems, and I'm listing a few of them to show the variety that I have been able to work on over the years. Initially, purification and growth of organic crystals, Gilbert Sloan, mentioned before, Mort Labus, Robin Hochstrasser, a distinguished optical spectroscopist in chemistry, and I had the opportunity to work for about 4 or 5 years with Ahmed Zewail, who was his student, who won the Nobel Prize for femtosecond spectroscopy in 1999. Subsequently, organic charge transfer salts and superconductors with Alan Heeger and Anthony Garito in physics. Conducting polymers, polyacetylene and polyaniline with Alan Heeger physics and Alan McDermott in chemistry, both of whom won the Nobel Prize in 2000. Polydiacetylenes, solid-state polymerization, working with Anthony Garito in physics. Research on lignin polymerization with Ken Pye of Reparp Corporation and Nicholas Nehes of the Griffin Company. Graphite intercalation compound studies with Jack Fisher in Material Science and Engineering. In fact, polyethylene oxide conductivity with metal salts. Beta primed and beta double primed alumina with Greg Farrington and MSE. Also slow crack growth in polyethylene copolymers with Norman Brown, a grand old man of MSE who was over 100 when he died recently. Boron pre-ceramic polymers to make boron nitride films with Larry Snedden in chemistry. Nickel chromium alloy oxidation with George Barron at Temple University. Amorphous chalcogenides, arsenic trisulfide films with Imants Laux in electrical engineering. Buckyballs and nanotubes, C60, C70, etc. with Jack Fisher and MS Smith in chemistry. We also worked closely with Rick Smalley, who won the Nobel Prize in 1997 for the discovery of buckyballs. Hole and electron mobility and aromatic crystals with Larry Shine at Xerox. Siloxane chemistry with Yanni Matthisons when he was at Gilleste. And metal rotation and organic crystals with Peter Beckman of Bryn Mawr College. All excellent people to work with, and I thoroughly enjoyed my time at Penn. Here are our Nobel Prize winners associated with the LRSM. In 2000, on conductive polymers, it was Alan Heeger and Alan McDermott, with Hideki Shirakawa, who was the postdoc who brought the original sample of polyacetylene to Penn. 1999, for femtosecond spectroscopy, as I mentioned, was Ahmed Zewail. And in 1972, Bob Schrieffer actually, got the Nobel Prize for Bardeen-Cooper-Schrieffer theory of superconductivity. Here are some extracurricular activities that I indulged in 1967. I taught a course at Drexel, and in 1979 I taught a course at Penn. In 1978 I joined the Thermal Analysis Forum of Delaware Valley, our local thermal analysis group. In 1980 I joined NATAS. In 1980 I also joined ASTM Committee E37. And from 1980 to 2000, I was an expert witness in state and federal lawsuits for several Pennsylvania law firms which involved thermal analysis. In the 1990s, I was a lecturer in Edith Turi's thermal analysis course at Brooklyn Polytechnic on simultaneous and combined techniques. And in 1990, I was a lecturer in Fison's TGMS course in Europe, introducing the new quadrupole mass spectrometer. Here are some of my activities in the 1980s. I attended every NATAS meeting from 1981 until today's meeting. In the 80s, I averaged 3 papers at every conference. I had many positions in the society, which are listed here. For my troubles, I was awarded the Outstanding Service Award by NATAS. And at the bottom of this slide, you can see some of my positions. But actually, if I go to the next slide, here I have blown up some of the positions I've held at NATAS during that time. Awards chairman, publication chairman, student award committee, program chair, symposium chair, ICTAC counselor, advertising manager for NATAS Notes, long range planning committee, and of especial fun was my time as NATAS Notes cartoonist from 1984 to 88. It was a long time ago, but many of you may not know we actually published NATAS Notes, and this particular issue, winter 1987, was 90 pages long and edited by Charlie Ernest. The grand old days of thermal analysis. In 1996, I was conference chairman of the 11th ICTAC meeting, which was held in Philadelphia. And that's for whom the bell tolls, it tolls for thee, to come to Philadelphia as an ICTAC conferee. To add a little humor to my talk, I thought I would throw in a few cartoons that I drew during that time. This is Catch Natas, the thermal bug. This is a cartoon about Charlie Ernest, who was professor of chemistry at Berry College. I'm sorry, the NATAS Proceedings Chairman is not available right now. He's preparing to celebrate his NATAS Fellowship Award. Here's a cartoon I drew for Harvey Baer when he won the Mettler Award. It says DSC plus TGA equals Mettler. Harvey Baer learned the ABCs of NATAS at an early age. Here's another cartoon that says, isn't this carrying in vivo testing a bit far, Dr. B? In this case, the Dr. B I was thinking of was Dr. Roger Blaine at TA Instruments. Here's another cartoon from 1985. I wonder if torsional braid analysis had its roots in the schoolyard. And finally, a cartoon about the British Thermal Methods Group, British thermal acolytes in training to become thermal methodists. As I mentioned before, here is the flyer for the 11th International Congress of ICTAC. This was a week-long meeting, and I believe it had the largest participation of any ICTAC conference. There were 600 delegates at this meeting. I believe that was the main reason that I won the ICTAC Distinguished Service Award in 2004. In 1990, I was appointed Associate Director of the LRSM, responsible for educational outreach. And here were our constituents. You can see everything from general public through industrial researchers, high school students, undergraduates, school teachers, graduates, postdocs, and colleges. This slide shows some of the programs that I started over the last, the first 20 to 25 years of doing educational outreach programs here. Some are one-day courses, others go as long as 10 weeks for research experience for undergraduates, which was the first program I started. And since it started, we've had close to 700 undergraduates working in our labs during the summer. Many of the programs involve teachers, research experience for teachers, monthly lecture series for teachers, programs for high school students. But the program I'm most proud of starting is the Partnership for Research in Education and Materials, PREM program, which involves collaboration between a major university lab with a minority college. We were the first to start this particular program back in 1999. Then it was called a CIRE, a Collaborative to Integrate Research and Education. And we worked with the University of Puerto Rico at Humacao. That was a 5-year program which was supposed to stop after 5 years. But there were 2 materials research labs in this program, Carnegie Mellon and us. And they were so successful that the NSF started the PREM program. And they have recently increased it this year, I believe, by another $50 million into this program. Time is passing quickly, so let me close by giving a shout out to my old friend Alan Riga and hope he is doing well. As some of you know, since 1977 I've also indulged myself in writing poetry and composing songs, many of which have scientific themes. In fact, I have written the NATAS song, which for a few years has been sung at this conference. I have also written the ICTAC song. I think this shows that it is possible to combine art and science, though how well remains to be seen. Let me just say how much I have enjoyed combining science and art for the last half-century, and tell you that I am a person who enjoyed going to work on a Monday morning. I hope that many of you young scientists feel the same way. Have a good conference.